So today let us discuss sets, relations, and functions for CET. Okay, so this sets, relations, and functions you will study in first PU as well as second PU. Few concepts are studied in first PU and few concepts are studied in second PU, but this is very important chapter as far as CET. Okay, because you can expect minimum 5 questions from this sets, relations, and functions, and they are really easy questions. So let us briefly discuss the synopsis of this. Okay, so sets, first of all, sets. So I will not discuss all these definitions because sets are well-defined collection of objects, and this is denoted by this symbol, and if a set which has finite number of elements is called finite set. No, I will not go into all these detailed discussion, but I'm explaining very few important concepts, but you go through this synopsis. That's why I sent this PDF yesterday only. Okay. So now let me consider. So this proper subset, this is a very important word, proper subset. Okay. So if A is a subset of B and A not equals to B, then we call it as a proper subset. Okay. If there are 2 raised to m subsets, then 2 raised to m minus 1 proper subsets. Okay. So 2 raised to m minus 1 proper subsets. So 2 raised to m minus 1 proper subsets. Union, intersection, all these operations are very easy operations. So here one of the important concept is, if A and B are two non-empty sets such that n of A is equals to m and n of B is equals to n, then the number of possible relations that can be defined from A to B is 2 raised to mn, because m into n elements will be there in the Cartesian product. Then 2 raised to mn subsets can be drawn from that. Therefore, total number of relations is 2 raised to mn. So in particular, the number of possible relations from A to A itself, if n of A is equals to m, then it is 2 raised to m square, because it is 2 raised to m into m. Okay. Next, reflexive, symmetric, transitive. So you are familiar with this reflexive, symmetric, and transitive. Anti-symmetric is a new word. Okay, if x comma y belongs to R and y comma x belongs to R, implies x is equals to y, x is equals to y, then we call it as anti-symmetric. Okay, so then function. So function. So go through this: function, domain, range. So different kinds of functions: constant, identity, absolute value, exponential function, logarithmic function. So even and odd functions. Okay. So this even and odd functions we studied in integration, but still you go through this. If f of minus x is equals to f of x, then it is even function. If f of minus x is equals to minus of f of x, then it is odd function. Sin x, tan x, these functions are odd functions. So cos x and x square, they are even functions. Then greatest integer function, then signum function. So meanwhile, I will explain one more function. Okay, so that function is called fractional part function. Fractional part function. Fractional part. Usually for CET, you don't need this fractional part. But sometimes this fractional part may give better idea to solve the problems. Okay. So fractional part, before explaining this fractional part, so this is the symbol. As you denote greatest integer by this particular symbol, the fractional part is denoted by this particular symbol. So if this is x, fractional part of x. So fractional part is very simple. If you consider 1.13 is equals to, so this is equals to 0.13, this is equals to 0.13. If you consider 2.7, fractional part of 2.7, this is equals to 0.7. So a very best definition for this will be x is equals to greatest integer x plus fractional part of x. We consider x is equals to greatest integer x plus fractional part of x. Therefore, fractional part of x. Therefore, fractional part of x is equals to x minus greatest integer x. X minus greatest integer x. Okay. So fractional part of x is equals to x minus of greatest integer of x it will be. So then we can consider the graph of this. So graph of this. This is 0. This is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Here also it is 1, 2, 3, minus 1, minus 2. Okay. So now, if you give the input as 0, if you give input as 0, what will be output? It will be 0 itself. It will be 0 itself. Then for 0.1, it will be 0.1. From 0 to 1, it works as an identity function. From 0 to 1, it works as an identity function. Okay. Then if you give the input as 1, then output will be 0. Output will be 0. Then if you give 1.1, again 0.1, therefore it is just like this. So it is just like this. Okay. So this is one line. Okay. Since it is parallel to x-axis, we can write this line as 1. Therefore, you can clearly observe the graph always lies between closed interval 0 to open interval 1. The graph always lies between closed interval 0 to open interval 1. Okay. So now one more thing, if you consider greatest integer of fractional part of, if you consider fractional part of minus 1.3, if you consider fractional part of minus 1.3, then the definition will be the element minus 1.3 minus, so what it is, greatest integer of minus 1.3. Okay, so this is equals to minus 1.3 minus of 1.3. So greatest integer of minus 1.3 is minus 2. So minus of minus plus 2. Therefore, it becomes 0.7. It becomes 0.7. Therefore, clearly you can observe all values lies between 0 and 1. All the value lies between 0 and 1. Okay, so this is how you can find the fractional part of negative numbers also. Okay, so now given a function f of x, then f of x is equals to 1 by 2 into f of x plus f of minus x is an even function. Then 1 by 2 into f of x minus f of minus x will be odd function. Therefore, every function can be expressed as, if you simplify this, see here, f of x is equals to 1 by 2 into f of x plus f of minus x plus 1 by 2 into f of x minus of f of minus x. If you simplify this, then this minus of f of minus x and my f of minus x get cancels, and 1 by 2 into f of x plus 1 by 2 into f of x will always give you f of x itself. Okay, so in matrices we consider sum of symmetric and skew symmetric using this original concept itself. So here also any function can be expressed as a sum of even function and odd function. Here f of x plus f of minus x will be even, f of x minus of f of minus x will be odd function. Okay, so then this fourth note, if a and b are two finite sets such that n of a is equals to m and n of b is equals to n, then first one, the number of function from a to b is n raised to m. Number of functions will be n raised to m. Okay, for example, if n of a is equals to 3, n of b is equals to 4, n of b is equals to 4, how many number of functions can be defined from a to b? Then it will be 4 raised to 3. The answer will be 4 raised to 3. So similarly, this b note, the number of injective functions or one functions from a to b is given by npm if m less than or equals to n. If, so see here, if m less than or equals to n, then only one functions will be defined. Otherwise, one function will not be defined. Okay, so let me show how. See here. So m is number of elements in A. Let me consider 1, 2, 3. Suppose this contains 1, 2, 3. Okay, so then, so here m, suppose if m is greater than n, then what happens? Suppose here I have only 4 and 5. Then 1 to 4, 2 to 5. But to become a function, this 3 should be associated with any of these 4 or 5. When it associates with this 5 or 4, then it will not be one function. Definitely it will not be a one function. Therefore, if m greater than n, then number of one functions are 0. Otherwise, we can choose if this element is greater 4, 5, 6, 7, 4, 5, 6, 7, then 3 to 6. We can choose in npm different methods. Okay. Then the number of onto functions, surjective functions, can be defined from a to b is equal to number of ways of dividing m things into n groups. That is, if n greater than m, then it is 0. Otherwise, we don't have a very simple formula. So if we have only 2 elements in set B, then only we have the formula, that is 2 raised to m minus 2. If set A has m elements, set B has only 2 elements, then it is 2 raised to m minus 2. Otherwise, we don't have very easy formula to find number of onto functions. Remember this. Then see this D, the number of bijections, that is number of one and onto functions from set A to set B is m factorial if m is equals to n and 0 otherwise. Okay, so if m is equals to n, then it is m factorial base, otherwise it is 0. So here I have mentioned a few examples. So already I have given these examples. Now this one also I have explained. This fifth one. A and B are two finite sets such that n of A is equals to n, where n is greater than or equals to 2, and n of B is equals to 2. Then the number of onto functions can be defined by 2 raised to n minus 2. I have given it for 2 raised to m minus 2. Okay, no problem. So here you have example also. Then this is very, very important. Sixth one, a function satisfying the condition f of x into f of 1 by x is equals to f of x plus f of 1 by x will be of the form 1 plus or minus x raised to n. 1 plus or minus x raised to n form it is. Okay. And f of x satisfying the condition f of x into f of y is equals to f of x plus y, then it will be of the form f of 1 raised to x. Okay. In fact, it is in the form of a raised to x form. Because if you consider a raised to x into a raised to y is equals to a raised to x plus y, it becomes. Therefore, f of x into f of y is equals to f of x plus y. This eighth one is a very interesting one. If f of x is equals to ax plus b divided by cx minus a, then f of x is equals to x, or f inverse of x is equals to f of x, or f of 1 by x is equals to 1 by x. So here I have mentioned the example also. 2x plus 3 divided by 4x minus 2, whatever it may be, if this a comes in the denominator as minus a, okay, not necessarily this. I will give you one more example. F of x is equals to 3x plus 10 divided by 20x minus 3. This is also in the form of ax plus ax plus b divided by cx minus a itself. Then no need to find f of x. Definitely it will be equals to x itself, or f inverse of x will be the same function itself, or f of 1 by x is equals to 1 by x itself. So they may give in CET, they may give f of x is equals to 3x plus 10 divided by 20x minus 3. Then find f of 1 by 10. They may ask this. Then the answer will be 1 by 10 itself. Answer will be 1 by 10 itself, because f of 1 by x is equals to 1 by x itself. Then this minor one will be the range of a cos x plus b sin x plus c is c minus the square root of a square minus a square plus b square comma c plus the square root of a square plus b square. So this one will be explained in trigonometry, the maximum and minimum values also. Okay, range means maximum and minimum values itself. This one will be explained in trigonometry also. So let me move into sheets problems. You can comment your answer. So yes, it is B. It is B. Because x square is equals to minus 1, it becomes x square is equals to minus 1. We don't have any such real number, therefore it becomes empty set. Next problem. Answer will be A, because here A union A intersection B. See here from Venn diagram. Suppose if these two are A and B, so A intersection B will be this particular part. Union A means it will be A itself. See here, these problems on sets, union intersection problems, can be done in 2-3 different techniques. So one of them is applying distributive law and other one is Venn diagram. Otherwise, you can choose some different values also. Take A is equals to 1, 2, 3, B is equals to 3, B is equals to 3. Check your values. Check your values. Then finally you will get this A. Therefore here option A. Yes, it is B, not A. I have explained this concept in synopsis. So 2 raised to m subsets will be there, but proper subsets 2 raised to m minus 1. Therefore, it is 2 raised to 3 minus 1. So it becomes 7. It becomes 7. It cannot become B and A also. Only one option is possible. Next question number 4. N of u is equals to 700, n of a is equals to 200, n of b is equals to 300, and n of a intersection b is 100. Then n of a complement intersection b complement. So yes, it is option C. So let's see how it is option C. Again, let me consider Venn diagram. So U should contain 700 elements. 700 elements should be there. So first of all, let me fill up with the intersection part. Intersection contains 100. So this one contains 100. And A should be 200 means 100. B should be 300 means 200 here. Even you can solve this using formula also, no problem, okay? So 200 plus 100, 300, 400. Therefore, 300 should be outside. 300 should be outside means n of A complement intersection B complement is n of A union B whole complement. N of A union B whole complement. Therefore, it is 300, option C. Next problem. It is D. It is D. So if you draw the Venn diagram, if you draw the Venn diagram, then this middle intersection part, so middle intersection part, 4 in all 3 subjects. Okay, so 4 in all 3 subjects, then 7 in physics and chemistry. So physics, chemistry, maths. If you consider this, then it will be all 6, 9 and 7. It will be all 6, 9 and 7. Therefore, all of this. Students who have taken exactly one subject, sorry, they have asked exactly one subject. Exactly one subject means, so this outermost part, this will be 6, 9 and 7, because if you fill up this intersection part, finally you will remain with 6, 7, 9 in this part. Therefore, all of this.